There's something special about a great crunchy tone, like that from my radical distortion pedal. But have you ever turned a pedal on and it just ends up sounding harsh or fizzy? And when you try to tame it, it loses its power. I'll show you what I mean with a Proco Rat. Now I'll start with my clean sound, which is my guitar going into a Universal Audio Dream 65, then to a TC Electronic Nova delay, and then finally to a Strymon Flint for some reverb, before going into my computer. It seems harsher and more fizzy, and then when I try to fix it, everything suddenly becomes dull and lifeless. Hi, I'm Gary Hess, and I started Phase 2 Music after a long career as an electrical engineer specializing in analog circuit design. I've also been playing guitar for over 40 years. This channel is about helping musicians understand tone on a deeper level, but in a way that's simple and practical. In this video, I plan to explain what's going on here. Now, I will be using a side-by-side comparison of the Radical Distortion and a Proco Rat. To perform this comparison, I'm going to play chords since they accentuate the differences more clearly than single notes. There's a reason why chords bring out this behavior more, and I plan to cover that in future videos. But for now, just listen. The Rat, Radical Distortion, go back to the Proco Rat. As you can hear, the Rat, like most distortion pedals, has a high frequency harsh fizzy sound, while with the Radical Distortion it's not as prevalent. Now let's take a look at what's really causing this difference. Okay, this is a frequency response, also called the Bode plot. The x-axis is frequency in hertz, and the y-axis is in voltage in dB volts. This shows how the pedal responds to different frequencies. Now, I use a piece of test equipment called an audio analyzer, in this case a Quantasylum QA403. Think of it as a super high quality audio interface with some additional signal processing capability. To make these curves, we don't want a very large signal because we want to keep the pedal out of its saturation range. So in this case, I use minus 60 dB volts, which is actually a millivolt, pretty small. The yellow trace is the Radical Distortion, and the red is the Proco Rat. Now, you don't have to understand everything about this tone. We're going to focus on two areas for today's discussion. This upper range is the treble. With clean sounds, this can create an airy and sparkly sound. But with distortion sounds, if I get too much content up here, it creates that harsh, fizzy sound. Now over here are the upper mids. This is where the power of your tone lives. For great distortion tones, what I like are strong upper mids and controlled highs. Now, most pedals try to fix the harshness with a simple tone control. Now, I'm going to go play the sound I played before and watch what happens as I roll down the tone control. Now let's look at the same thing again with the Bode plot. I'm turning the tone control down. So what happens is not just reduction in the highs, it's also reducing the upper mids. The highs went down, but so didn't the upper mids. And that's where the energy and power of the distortion lives. Now you can try to compensate for that by now increasing the volume on the pedal. I'm going to do that. But looking at it now, although I did increase that, you still don't have as much of the upper mids there. Because I cut the highs, I cut the highs and the upper mids both. Now if you look at this graph right here, you see a really interesting behavior between the two curves. Notice that the Radical Distortion pedal, the slope here is considerably steeper for cutting the high frequencies compared to the Proco Rat. This is because my pedals actually use second order filters, while tone controls on most distortion pedals use first order filters. In general, second order filters can cut frequencies at twice the rate as first order filters. This allows my designs to control the harsh top end while keeping the upper mid energy intact. That's why the radical distortion sounds smoother but still has power. There's actually a lot going on how I shape the tone and saturation characteristics of my pedals, and I'll break that down in future videos. On this channel I'll also be doing gear reviews and product comparisons, but with visual explanations for the technical details. Along the way I'll also branch out into other areas where music and technology intersect. If you found this interesting and helpful and want to understand your tone better, consider subscribing, and thanks for watching.